más éxito. Gracias y continuamos con la tercera ponencia. Como os comenté antes, la ponencia la va a dar Andrew, que es el Andrew de Delahunt, que la va a dar en inglés. Si alguien necesita la traducción, los compañeros le darán el correspondiente traductor. Y es responsable de Seguridad e Ingeniería de IPAF y, como decía antes, hemos visto que en la propia exposición, en los stands, tienen un simulador de plataforma elevadora. Cuando quieras.
Gracias. Buenos días, bienvenidos. Gracias, Osalan. Hablo español un poco, so I'm sorry, but I'll have to speak English, otherwise I'll end up speaking French. I live in, as I said, this is not me, but IPAF, I'll just talk a little bit about who IPAF is, what the machines are, and then the technologies that we use in training. As I said, my background, I'm an engineer. I worked for manufacturers of trucks and buses and then of these machines, and now work at IPAF, who is a not-for-profit organisation. These machines are typically called cherry pickers or aerial work platforms. Here in Spain, they're PEMP. In France, they're POMP, and mobile elevating work platforms. They're machinery that allows people to access a height and to undertake work at that height. So their solely is to provide that access. So the people who are using them are typically have another activity. They may be painters, they may be construction workers, so they may be working on wind towers, as Eli spoke about. So their goal is not to operate the machine, is to drive the machine. Their goal each day is a specific work activity that is at height. IPAF itself has been around since 1983. And we're in 70 countries throughout the world, from the USA, from Mexico, Brazil, here all throughout Europe, including here in Spain, and also throughout Asia, India, China, etc. So a global spread, mostly, as quite clearly happens, the safety of people working at height is the same whether in all of these countries. It's a not-for-profit organisation, and the main mission is to promote the safe use of these powered access. As you see here, a construction site, and there's quite a busy activity. There's lots of machinery, there's cranes, there's trucks, there's lots of people working around. So working at height is not a single activity on its own, but it's a combined activity working with many other people quite frequently. And we see, as we look towards the future, that with the new technologies of drones, and soon there will be robotics, the work site in the future is really going to be fundamentally different. I'll just show a little bit about some of these machines so we can get a feeling for what these MEWPs are, the PEMP. We see here their idea, their objective is to be able to work at height. So there are people who are at a very large heights, very high, working on construction or setting up lighting for the Christmas decoration. I do apologise for the people who need to use the translators. They're working on tunnels and bridges. So we see here a machine that looks under the bridge to then be able to inspect the bridge. They're working on towers, be they mobile phone towers or radio towers. They're working in tree trimming activities, tree climbing and tree trimming. And all of these are quite disparate, quite different work environments, and they can be quite hostile. This is up in the north of Sweden, so it's quite a hostile environment. They're working on shipbuilding and manufacturing activities. And this is a key one. They're working close to electrical lines So there's a number of high-risk activities that have been done with this work. And just a little shout out to Eli, the work also on wind towers, and these are very remote, and so the people who operate these machines need to be highly trained and need to be really quite independent of what they do. So that gives an idea about what the machines are and how they're used. I'll just quickly talk about the design of the machines and the technology that these machines have to ensure the safety of the machines. All of the machines now, the MEWPs, have load sensing. So this is monitoring to say that make sure that the load or the weight in the platform is within the limits, and so we don't have instability or stability issues. We quite often have what's called a work envelope, so where it can reach out to and access. The further out it reaches, obviously there's a stability concerns there. So we must make sure that these machines can work within their limitations. Some of the machines, to ensure that to be able to have higher loads and to be able to lift more equipment or more people, will have restricted work envelopes, and that has to be monitored and restricted so that the operator can't go beyond the limits. And there's an important one here called secondary guarding. When we talk about working at height and we lift up and we'll change these lights above us, but we're working in quite enclosed areas with obstacles. And if you run into the obstacle, you can at risk of being entrapped or being crushed. And effectively, I'll do a little demonstration. We'll be working up, moving up, and suddenly we move into something behind us, and we're crushed there onto the control panel, and that can cause a fatality. We also can cause that the machine can continue to move further, trapping you, so leading to a fatality. So the manufacturers have developed technical devices that's called secondary guarding that automatically activates when the person is crushed onto the panel and stops the machine and raises an alarm. So there's a lot of technical safety devices that have been introduced by the manufacturers. Another one here, just quickly, is collision avoidance, especially in terms of working on aircraft, and they're very expensive and they don't like to be hit. They cost millions of dollars from just any collision. So there are collision avoidance little sensors that are activated. The difficulty, of course, is that when you're working in very, very close scenarios, you might be up in still erection. The collision avoidance sensors acknowledge that you are close to where you want to be working. So there's a compromise between being able to get close to the work site and being in this enclosed structure and not colliding against these. Other technologies, most of the time these machines are rented and are provided to specific work sites, and they are delivered in the middle of the night or early in the morning and then picked up at the end of the day. So we're asking that our truck drivers deliver these machines in a dark environment. So having suitable lighting on the machines to be able to load or unload off the truck is critical for the safety of the truck drivers. And I'll just touch on this briefly. We've identified that loading or unloading of machines on trucks is a high-risk activity, and there are a number of accidents. So we'll see later that we've introduced training for this activity, because it's not just taking a machine and operating the machine, it's also the whole life cycle of the machine, being able to deliver the machine to site, move it around the work site and operate it. We have to consider all the risks for that. So that's just a little bit about what the machines are and the safety that they have. So now we'll come back to the training and what training is. So as I said, IPAF is a member organisation. We don't provide the training, but what we do is we represent our members who are manufacturers, who are rental companies, who are users, and similar to the GWO, we set a training package that can be delivered anywhere around the world. so that we know that the people who are then using those machines can use them safely. How do we know that the training package is any good? Is because we have what we call the accident portal. We ask all of our members, all the people who use the MEWP throughout the world, to report when there's an accident. And we collate the data, we analyse the fatalities, and we analyse all the minor accidents and near misses where no one has been injured, but there is a possibility. And we identify how we can improve both our training packages, our guidance to people who need information about how to use the machine, and we also run safety campaigns identifying the key issues. So we're actually trying to use this empirical data from accident reporting to improve our training. We see here the slide on the left, we talk about, there's a couple of charts here. Key one here is the fatalities in the UK. And we see over this accident reporting portal was introduced in 2012, and over the last 5 years we see a significant reduction in fatalities while using these machines. And that is really been, I think, a big factor of that is by being able to have better training and better awareness of where these accidents are where they're being caused from. Unfortunately, we see in the graph at the bottom an increase, and that's over the last 5 years as well. That's globally all the accidents that have occurred, and we see an increase there. Partially that's because we are increasing the amount of machines being used globally, but also it identifies that we need to have more training in certain areas, particularly in North America, where there's a significant different approach, but also in places where burgeoning markets such as India and Middle East. So using this empirical data has really greatly improved the type of training we have. What we have also gone beyond is saying, okay, we have one single operator training. As you see in the chart on the right, there's a number of different machines. So we have select categories that provide different training to be able to better identify the risks for use of those machines, whether they're machines being used on a vehicle, such as a truck or van mount, or their scissor lift, or boom lift, or these other machines would have different risks on them. There's also a training package specifically for load and unload. So for loading and unloading, the machine, which we said for transport, is a high-risk activity. On the bottom, unfortunately, it's cut off there. It's for harnesses, because obviously the use of a harness at height is important, is a compulsory activity. What also needs to be trained is for people to be able to inspect their harness and understand what is a good harness and when it's a safe condition. And finally, the last one, this new one that's been introduced, is a thing called MEWP for managers. Because we recognise that a key aspect of any work activity is having good management, good supervision, and safe planning. It's what I like to say is any fall from the height starts from the ground, right? It starts from your planning. It starts from the boss making sure that you have a safe workplace, that you have the right machine, and you cut out risky behaviours. So we have specific training for that manager. Now let's talk a little bit about the technology that we're introducing to our training. This, what we call e-learning, is a computer-based training package. And this, I think, is very, very important for the managers, but also for operators who can sit there and do the theoretical information on the computer. Right? A little bit about this. We see there's a number of different slides showing what the training is. You run through like a computer package. It provides interactive selections and scenarios about how the machine is used and what is a safe activities, or what are the high risk, the hazards to be identified. We talk a little bit about fall protection and use of harness in there. So I said it's an interactive computer-based training package. the key benefit of this is for people like managers, this can be done 1 hour each night over a week or over 2 weeks, and so you can provide this outside of your work time, so you're not having to take time off to go and do the training. Or another key benefit of this e-learning is that we can tailor the language specific for the location. So we're seeing in places like Singapore, where there's a number of workers, or Singapore and the Middle East, where there's a number of workers who are not from that country. In Singapore, Bangladeshis, Middle East, you have a lot of Filipinos, people who then have different language and don't have the same language skills. By being able to get online and use the e-learning, that language can be specific for the worker, the trainee. We also are starting to utilise what's called BIM, so Bim Modeling. So this is part of the building, it's a building information module. It provides, and you can see on the left, the different machinery as a computer module. So then what this does is during the planning stage, it allows you to create in 3-dimensional or 5-dimensional the worksite that you have, and to be able to plan through this process. So what is typically sort of done by architects and by the worksite planners, who identify where the machines will go, where material is supplied and stored, and can build up through this modelling, can build up that worksite. By being able to provide the modules, the little models onto the computer, we see here on the bottom right, we can simulate the worksite and simulate how the construction goes through. And this is now starting to be used, and we'll see here, it's starting to be used in places like Norway, who have done projects on their roadways and have completely, simulated their whole work, the project, and found that they've made a number of efficiency gains and safety gains. And we see here the significant cost savings by using this BIM modelling. So it's been using able to predict when the machines will be in place, when the materials will be delivered, and they can find significant cost savings. Now, one of the, sexy parts of training is the use of virtual reality simulators. You might have seen on the stand outside that we have a simulator, and it's not an IPAF simulator. We don't develop the technology. It's a burgeoning market. There's a number of different simulator providers here. So we had to look and say, how can simulators be incorporated into training, and to what level? Now, whenever we have training for an operator, we put the trainees onto the machine and expect them to be able to drive and lift that MEWP, and to make sure that they can actually operate safely. And that's done, outside in a car park in a nice, safe area. And the question is, can we replace that? Can we go purely to simulators? And this year we've made a significant investigation, and the outcome is that at this point in time, machine operation, any training, you should have to use a machine to operate. So when you get in a car, you get your car licence, you don't do it only on simulation, you actually have to drive the car. And we think that still is maintained. So then how can we use virtual reality simulators? How can we make this bring a benefit to our training? And we see, what it can do is it allows people to test and to train in a safe environment and to put themselves in high-risk areas. And we see, through our accident reporting, we see that there's a number of significant risks: electrocution, falling from height, and, as I said, being crushed. So the idea of being able to use a simulator is to put you into a situation that's more technical, it's more complex and requires more skill, and there may be a high risk element, and the person can train and practice in this environment in a safe manner before they actually then go and operate the machine in a real situation. So IPAF's position is that simulators are a key part of training but can't replace being on a machine. But what they can do is provide a safe environment for these high-risk activities. And if anyone hasn't actually tested the simulator, I urge you to go and put it on. It is amazing how realistic it is. Wearing the goggles and being on the machine, on the simulator in the platform, it is a very, very realistic simulation. The final interesting aspect of the new technology is what's called augmented reality. And this is where wearing the goggles, you can see animations that can help you with what you're working on at this point in time. What we see here is people are using it for service training, for people using the service technicians who need to work on the machine, and they've been able to see little simulations, little animation that identifies where the faults on the machines are, where to repair, what items to look for. This use of augmented reality will start to take place, will start to really be taken up throughout the market over the next few years and provide a quick and efficient way to be able to explain to, on the site, on the job site, to technicians how they can repair the machine. I will finally, I'm about to finish, yep, no problem. I'll talk just very, very briefly about the future. As we saw on the first slide, the work site is going to change and going to change in a hurry. And we will see a lot more robotics. And what we'll see is we'll see robots on the work site, but we won't see people disappearing. We'll see a lot of co-working, which is sharing the work site beside robots and having to work alongside these robots. So there's significant risks that we need to address there. We'll see a lot more automated movements of the machine, whether they're coming off the truck, which we identify as a safe area, or machines moving around the work site on their own, or moving material, particularly moving heavy construction material on their own. So this is something that IPAF recognises has to be addressed to make sure that any worksite remains safe, even with this automated or robotic movements. And that's all I have. Gracias. Thank you for your time. Thank you for listening. And gracias a Osalan.